This looks like spy movie tech, but it's actually something you can build yourself. I'm Nikki Griffiths, and I empower others by making tech less intimidating. So let me show you how to build this step by step. Here's everything that you'll need. An Arduino Uno, which is a tiny programmable computer, a breadboard, which is just a plug-and-play board for wiring and prototyping, a photoresistor, which is also called an LDR, which stands for Light Dependent Resistor, a 10 kiloohm resistor, a passive buzzer, and a laser pointer. No soldering required. The Arduino Uno powers the circuit. On the breadboard, the rails, which are on the sides, both the negative and the positive, are connected vertically. In the middle of the breadboard, all of the rows horizontally are connected, but the columns are separate, with the 5 volts going to the positive rail on the breadboard, and the ground going to the negative rail on the other side of the breadboard. On your photoresistor, you should see 2 metal legs. One is going to go to the positive rail on your breadboard, connecting to the 5 volts on the Arduino Uno. After plugging the photoresistor into the positive rail on the breadboard, you can plug the other leg of the photoresistor into the middle of the breadboard, along one of the horizontal rows. Now we need to connect the photoresistor to the Arduino Uno, so it can receive a signal when the light changes. Plug a jumper wire into the same horizontal row as the photoresistor. The other end of the jumper wire will go into the analog input, or A1, on your Arduino Uno. Next, we need to complete the photoresistor circuit. Take your 10 kiloohm resistor and put it in the same horizontal row as the photoresistor. The other leg is going to go into the negative rail on the breadboard, connecting it to the Arduino Uno's ground. We need to connect the passive buzzer to the circuit as well. On the passive buzzer, you should see 2 legs labeled positive and negative. The positive leg is going to go into the digital pin 9 on the Arduino Uno. This allows the Arduino to control the passive buzzer via the digital pin. The negative leg is going to plug into the breadboard along the ground or negative rail. This connects the circuit for the passive buzzer. All that's left is to write the code to tell the components what to do. In the Arduino IDE, or Integrated Development Environment, you are going to create the code to tell the Arduino what to do with all these signals from the components on the breadboard. The Arduino IDE uses a simplified version of C++. First, you're going to calibrate the LDR to the expected input, in this case, a laser pointer. After a few seconds, it'll update the initial threshold values with the new calibrated threshold values. Next, you're going to create a variable called a bool, or a boolean. This can be set to true or false. Give it a name like beam broken. The rest of the code is essentially just going to be an if and an else statement. If beam broken is equal to false, the buzzer doesn't sound. However, when beam broken is equal to true, the buzzer is activated and makes the beeping sound. So when I walk through the beam and the photoresistor stops seeing the light from the laser pointer, it sends a signal to A1. A change in voltage is detected. The variable beam broken is set to true. The alarm is triggered. And that's it. That's all it takes to build your own working Tripwire alarm. Check the link in my bio for step-by-step instructions and the code to run the Tripwire alarm. I'm Nikki Griffiths. Follow me for more tech tutorials like this, and let's start building together.